Okay, today we're going to do a build video for the large 3D printed battery operated walking Tomy Pocket-bot. And let me move a few of these parts out of the way. If you've watched the earlier videos, this was the prototype one. And I wanted to do, maybe I should move that out of the way too. I wanted to do one in a translucent red plastic. This is PETG because I wanted to know how the Bamboo Labs A1 printer would handle PETG. And I'm going to backlight it with this dollar store flashlight so you can see it is translucent. You can make them light up if you want. The only thing about printing the parts in the PETG, which they turned out fantastic on the printer by the way, is I won't be able to glue the parts together with my normal weld-on number 16, the miracle glue that literally melts PLA plastics together. It won't work at all with the PETG, so we'll end up using the E6000, which takes a lot longer to dry. So I'm not really 100% sure how far this build is going to go. In other words, there might be a part 1 and a part 2. We'll see. The original design was I wanted to use one of these blue TT gear motors, and the blue one's because it gives you the 1/90 gear ratio reduction, and what that means is the output shaft turns once around for every 90 revolutions of the motor. It'll give it a nice slow walking speed, and a slow walking speed is important because the Pocket-bot purposely in the design of the clawfoot walking tips the body forward and backward. And if you have a really fast, frantic walking speed, that's a lot of mass having tipping forward and backward, and it makes the robot unstable. This particular first one doesn't have the TT motor, and it has a different motor which I jerry-rigged around just so I could test the functions of everything. And that's about what we're hoping for. So I think these will be a lot quieter. That particular gearbox is quite loud and noisy. So you start with your TT gear motor and snip off these little lumps. Those are leftovers from the original TT yellow motor design, because they used to have a strap that came around and held the motor in place. And now they just have the plastic that holds in place, and whoever did the design work forgot to take those off. But we need those out of the way so that the leg linkage parts we're going to put on there don't rub on that and cause friction. Then you've got the two contacts that you're going to solder to. Kind of snip that big chunk that right there out of the way and solder 2 wires on and route them out to the side like you see here. That's going to be important as we progress. The cams themselves print flat without supports, and you've got your D-shaped indent, and you just put the cams on there like that, one on each side. We don't need to secure them. This bottom frame is going to hold that gear motor and the leg linkage parts and all of that stuff in one. And you'll notice there's cutout places where I could have brought the wires off the motor out, but there's also, if they show up, there's also these side holes. Maybe I should turn this light on, sometimes that helps. There we go. So you got these holes here, and you got these side holes, and the motor itself is going to go in motor, let's get further back. It's going to go in motor down. So the first thing I'm going to do is try and fish these wires. I think this will show up. I'll fish them through the first hole. It doesn't matter if you go with the front or the back. And then we're going to, in the end, fish them through one of the side holes. But for right now, I just I need them oriented so they're going somewhere. Then you can see this whole motor is going to just slide down in there and just keep pulling those wires. And you don't want the cams in so far that they're rubbing on the frame. Actually, we're kind of learning this together. I haven't built one of these with one of these TT motors yet, so maybe they don't fit. Seems rather taut. So let's investigate this. I'm not sure. Trying to see what might be hanging up. Nothing up here. Nothing there. The motor part seems to have started. I think it should go further down. I realize there's a stop down in there, but that's not all the way. I think we should be able to go further. Oh, I was just hitting on this cam. I had this cam pulled out so far that it was simply hitting on that. Okay, so we know it's going to fit. I don't really want it down in there yet. I just was doing a test fit to see whether it was in fact going to fit, and it does. So now let's lift the motor back up. There we go. Because now when we slide it in, we're going to want to make sure we get these leg parts going down in there at the same time. So start one of those. It sits on there like that. Start. I guess I need to route these wires through the side like I was saying earlier now, because if I push those leg parts down in there, I won't be able to do that later. See, this is what happens when you design something and have to wait 3 weeks to build it. I was waiting for the motors to arrive. You kind of forget the logical order that you're supposed to be doing things in. Or at least I do anyway. Okay, here we go. Put that. And yep, that's all the way down. And all this stuff should move freely. We do have a 3mm rod that I'm going to end up using as an axle. There was a hole all the way through, so you can see how that goes through the pin of the legs, When we end up putting this in the body, that pin will be held in place. I can't think of any reason why we'd want to fool with it more than that. One thing I think we probably should do, since this is the first time any of this has been assembled, I haven't done it off camera, is I'm going to run it and make sure everything is moving freely before we go any further. I don't want to hear any binding or anything. Okay. Looks good. And in fact, if I bring the wires out to the front, that should be walking forward. Of course, clawfoot walkers you can make walk forward or backward, and that would be going forward. Now here's this little piece here, which we're going to glue on to the top, and it's going to make sure that that motor doesn't lift out on its own. So we'll end up putting some glue on there, and in this case, this gray plastic is PLA. So with this gray plastic, I can go ahead and use for my favorite PLA glue, which is the Weld-On number 16, because it's so fast and because it actually melts the plastic. So it makes a really secure bond. And I think we'll just put a dab there, put a dab there, and just push that on down on there. And let's seal this up. Okay. I think I'm going to go ahead and route these wires up through here. Maybe. Here we go. Like so. I guess we could go ahead and put the feet on. Now these are the clawfoot feet. Again, this is black, so I printed these in PLA, which means I'll be able to use the fast number 16 glue on these. And I'm going to put glue on all these inner wall surfaces and then just push them up on the legs. There isn't a front or back, they're symmetrical, so you can't really put them on wrong. I can't think of any reason why we can't do this step now. So if we find out that there was a reason we shouldn't do it now, we'll be learning together. Like I say, I've done 3 other projects since I designed this, so I do tend to kind of forget if there were, you know, an order to doing things, a logical order to doing things. So we got that one setting up. Let's get the other one. So this can be basically gluing and drying while we look at the others. There aren't all that many parts to this, which is nice. That. And there. Okay, let's let that sit and dry for just a second, and we'll talk about the rest of this build. Here is the back, and I basically glued in a 2 AA battery holder. There's a place to run the wires through, and then there's the battery cover itself, which prints in 3 parts. You have this main battery door piece, you have this knob piece, and then you've got this inside piece that slides as you move it. So basically you put that one in there, and when it's pushed all the way in, then you just slide that over and it locks in place. As far as painting it, I just went with some acrylic black on here and brushed that on, and on the silver chrome part, that's that let me show you the container. There we go. Moloto. This is the refill size. This is the best way to buy it. This is 30 milliliters. It'll cost a fraction of what it costs if you buy the Moloto pen, which kind of looks like a Sharpie. Just buy the refill. You can squirt a little bit of this on a plastic bag or a little bottle cap or something, and then just use a paintbrush and paint it on. It's the most cost-effective way to get a chrome look on something if you're going to be doing it by hand. And I just touched up those rivets on there for some detail. Again, this is the back. And on the front, the arms, these all print as one piece, basically on your print bed, vertically like this. No supports required. And I printed these in a black PLA, and then painted the claws chrome. Did some more of the black paint job around here, and I did a black paint job around the switch area and some chrome work, as you can see there. Now the eyes, those print as a separate piece, as you can see, it's a separate piece. And then glued into them, you can use up to 5mm LEDs. I have 2 LEDs in there. They're the self-flashing type, so they'll start flashing between 2 and 2.5 volts, basically. They're wired in parallel. I put a capacitor across there to help filter out any of the hash or noise that might come from the battery motor that might make them flash erratically. And also put a little current limiting resistor in there. In this case, this one's just a 39 ohm resistor, but in some of the robots that I've done in the past 3 weeks, I went ahead and used up to 150 ohm resistor, and it kind of actually might work a little bit better. And then you just glue the eyepiece in place. That way you can paint all the chrome first and then glue the eyes in so that they'll light up. You don't have to print the eyes in red. If you had green LEDs, you could print them in green, or you could print them in clear PLA or something, and light up whatever color LED you had back there, or use a color changing LED. Anyway, there's going to be a positive and negative off those because that's the way LEDs work, and I brought that down and already soldered that to one lug. That means I'm going to be bringing down one of the battery wires from the back and solder it to the middle, so that anytime the switch is switched up, it'll put power to those flashing LEDs. And that same power, I'll end up soldering one of the motor wires to, and the black wire, which is negative, will connect to the negative wire from the battery pack as well as one of the motor wires. So those three will all join together, and I'll probably put some heat shrink around those when the time comes. So let's continue on. Let's see how we're doing here. This should have had time to have set up. So basically you can see how there's a ring around that, and there's a ring around the bottom here. So when you set this in place, you can see how that can capture, here, let's turn everything this way. You can see how that would, in the end, when the front and the back are on, that's going to keep that 3mm rod from coming out. And this all fits straight up in there. So that means that we can put our glue around here on this flat surface, and we can put some right here, and that'll glue to the back of the battery box and secure everything. Now if I'd printed the entire toy out of PLA, I would use the weld-on 16 here and here. We'd slap them together, and less than 10 seconds later it'd be done. But I didn't, because this is PETG. I'm going to go ahead and use the E6000, which isn't going to set up that fast. And that was, we'll just have to see whether I can keep handling things or if we have to sit and wait. And this is a little plugged up. Let's unplug that. Let's go ahead and put some around this back. And up here. And I just want to make sure that it's square. Gluing the back to the back of the battery box will help you make sure that you've got the thing on there square and right. So it's going to go like that. And we do have these big old wires from the battery pack. Now a person could cable tie them to that loop on the top of the motor if you wanted to make sure they stayed out of the way of that stuff. On the other hand, if they're just tucked around in here, I really don't know where they could go that would become a problem. In other words, I think it would be okay. But let's go ahead and take the black wire from the battery and the green wire from the motor, and let's twist those together, because we know all our common grounds are going to go together. And because I test run that motor earlier, as you saw in the video, I'm pretty sure I've got it walking forward. We will check that again and see if this soldering pencil is warmed. Okay. And if we could get the black wire from the eyes joined on there. And I need some solder on there for sure. Can't just melt wire. There we go. Alright, now I'm going to put some heat shrink tubing around that to keep that from shorting against anything, but I do want to make sure before I go that far that I remembered right that the white was positive when it's walking forward. So I'm using my external battery pack right now just because it's easier. Let's see. Yeah, we'll be good. That will be walking forward. So that means we can take a little piece of heat shrink tubing and stick it around all those wires that are connected together for ground. And I need a heat source. We got a little torch here, and let's just use this. Like that. Just fold that over. Okay. So that means now I should be able to take this positive and solder it to, well, maybe I should do the motor one first. Let's take the motor one, let's make sure it's tinned up, got solder on it, and let's join it to the top of the switch. You could put in a switch that has a center off position and get forward and reverse walking. They do sell the same little slide switch with 3 positions with center off. So if that was important to you to be able to walk forward and backwards, it's quite doable. It's not hard at all. Where it would get tricky is getting the power to the LEDs, but you could do that with 2 diodes. There we go. And that switch should be off. I've got to set this soldering gun where it won't do any damage. Then let's stick in a couple of batteries and see if things are wired up right or if I've made a mistake somewhere. Weird. Good walker. I'm not sure why the eyes are flashing when the switch is off. Now that's very strange. Where did I goof that up? Because it's is there enough leakage? Must be something wrong with that switch. The motor is not running. Did I lose a ground connection up here? No. How strange. Let's take our wires off that switch. Let's investigate together. Soldering gun has already cooled down to the point where it won't melt solder. Okay. So oh, look at that. You guys didn't even say anything. I soldered the motor wire to the center of the switch, and I'd soldered the positive to the LEDs. I meant to solder the battery to the center all by itself, and the motor and the LED wire to the other terminal of the switch. So basically I had a battery power soldered to the LEDs all the time, and nobody out there called me on it. Here we go. Now we should be good to go. Yes. Yes, yes, yes. That's very good. Stupid little mistakes like that keep life interesting. Okay, so now comes the sort of the tricky part. Trying to glue the halves together without doing 2 videos, since I don't edit videos. I'm thinking about using these to go around the body and hold everything together until the glue sets up. Before I put any glue on anything, let's experiment with just tucking all of the wires in and making sure everything is going to fit. Okay, it looks like everything will fit. Everything will be fine. I'm going to put some glue in these white areas right here on either side of the eyes, along that black part that I painted there, and then of course on this bottom ring, just like we did for the back. Just put a few drops around there of that. and as I said here, right near the where I painted that black, and then either side of the eye, because it's a big flat area. And then let's tuck those wires in there again. Don't fight me, wires. The wires are fighting me, especially that green one. There we go. Get on there. I want to cap the glue up before air gets in there and dries that up. I'm thinking while I'm tying this together, maybe a clothespin on the very top of the head to kind of hold that together while I'm working away down here, like that. See, my idea was to take these twist ties, bread twist ties or whatever you want to call them, and just kind of give them a twist tie belt to hold this whole base together while we're waiting for things to dry. And I think that'll work fine. So I don't think we really need that. Now you have the round antenna part on top of the head. As long as I was printing in translucents, I went ahead and printed that part. And so let's glue that on. It goes right on the top. That should help hold the top of the body together. Because there's a little, see, there's a little recess place for it. Just kind of wiggle that around, and if you have a preference to where it sits, that's good. Okay, now we're down to the dome. These are sold as clear ornaments in all the craft stores and online. This particular one is a 70mm. And of course there's ones that have an outside flange and one with the inside. Both should work. The inside one's going to fit tighter, which is what this one just happened to be. And my preference is just to put a little bit of the E6000 on that joint on the side slit. And nowhere else, because that way if I need to get back in there I can. There is a hanging hoop on all these, and I just took the snips and nipped it off. I'm going to put that little ugly place where I nipped it off in the back, so it doesn't even really show up. And then you can just kind of push it down. Now in the end it might be good if I took some tape or something and went around and held that all the way down. But because we're basically done, with the exception of the green twist belt, it's time for a complete test. That's exactly the speed I was hoping to get. It's much quieter than the first one. It's got the good walking action. It's got the blinking eyes. So there you have it. It's actually an easy build, and you were able to even learn from some of my mistakes while doing the build. STL files are on Thing-i-verse. I'll put a link to all of that down below. The earlier videos, I'll try to remember to put links to those as well. And I think that's about it. The only parts you really need to order would be the TT blue motors. So far I've been finding these cheaper on eBay. The domes from any craft store, local or online, 70mm. A dual AA battery pack. A slide switch if you want to use the same mounting hole I put on there. It's 19mm between screw hole mounting spacing. Paint if you're going to paint it. And it'd be interesting to see it in other colors. I really like the way this translucent red ended up, but they also make translucent green and yellow and blue, and some of those other colors could look really cool too.